Good morning and welcome to our quick bite. For today, we have Daniel Alter, Professor of Restorative Dentistry at the City University of New York, as well as the Executive Editor of Inside Dental Technology. This webinar is One Fire to a Perfect Restoration. My name is Madeline Holzer. I'm the Education Specialist at and we are happy to present this to you today. Please keep in mind, if you have any questions, please indicate them in the questions box and we will address all questions as time allows. And with that, I'll go ahead and turn it over to Daniel. Good morning.
Good morning, Madeline. Thank you so much for the introduction. And thank you everybody for joining us this Friday for this quick bite regarding the transition zirconia. It's an exciting new zirconia. It's a new evolution of zirconia. But you know, not all zirconias are alike, and certainly some of the things that we're going to be discussing today is how to attain the best results from your zirconia, from transitions. And a lot of it has to do, and we'll talk also about some troubleshooting opportunities and what certain things are, certainly with sintering as well as nesting and so on. But the results that can be attained with the transitions is truly remarkable, and I'll demonstrate what I mean by that. Now, as far as the Zirlux transition, it's a new processing of way where it's a hybrid colloid processing, making the zirconia that provides not only the truer, richer chroma, but also provide a level of transition for where the blue color or the incisal color really exists. So where on the lower end of the puck, you have a richer chroma, and then as it moves up, it transitions, and then at the incisal edge, obviously you have more of the enamel, and therefore it's more of the yttria composition. And it's a composition of, it's a 4Y yttria, but it's a transition of sort through their processing that allows for a truly aesthetic and really remarkable results. So it's offered in all 16 Vita Classic shades, as well as some of the more challenging shades, which are the bleach shades. And when I say challenging, it's not so much for zirconia, because traditionally zirconia has been higher in value. But nonetheless, bleach shades were always difficult to achieve that high value for the bleach, but yet to still have the translucency to make it look as natural and as viable as it is. Again, it's the way that it's manufactured allows for the transitions to have a consistent and closer to the shade tab than any other zirconia on the market. So it's really remarkable, and especially when you go through the process of really sintering properly, and we'll talk about calibrating your furnace and purging your furnace and nesting in a little bit. But if you dial in and get the results, the results are absolutely outstanding, and I'll show you some of the test results that I've done personally as an independent. It fits into all 98mm diameter formats, so whether it's 14. Currently, they're available in 14, 18, 22, and 7 in all 17 shades. So depending on what it is that you want to do. Now, that's something that's of critical importance when you're looking at this type of zirconia, because remember, the way it was manufactured, the way it was processed through a hybrid colloid processing, it's very important to select the right thickness of the zirconia, because again, if you're nesting it and if you want a little more chroma, then you want to nest it further down towards where it's more chromatic, and therefore it's the cervical of the tooth, and where you nest it, and then as it goes up, you're getting into the enamel or the more translucent, the blue colors. The way you nest it is going to be prudent on how the end result derives. So if you want to get the full gamut of what the incisal, the blue incisal smart technology, then the proper thickness of puck needs to be selected for that restoration, and you can do that depending on what kind of cam software you have. You can calculate the exact thickness of the needed thickness of zirconia, and then you want to place it or nest it in a way that you're going to gain the greatest benefits from it. So the anterior, and this is what also is fantastic about this line of zirconia. And again, it's a new evolution, it's a new factor. It's not the same as other zirconias because it's processed differently. but it is therefore allows it to be both anterior and posterior, as well as a complete, if you're doing a single unit restoration, if you want to build up, if you want a micro layer, whatever the case may be, this zirconia line is really versatile because you can, in essence, do all the functionality that in the laboratory. So if you're doing a anterior full contour, you have the transition from the chroma through the incisal edge. Or if you're doing even a 14 unit bridge, which, again, that's the benefit of this type of zirconia because it provides the strength of 1100 to 1200 megapascals throughout. So it's really up to the laboratory what it is that they want to decide to do with it. And again, it's indicated for the aesthetic high anterior type of restorations from a single to 3-unit bridge or whatever have you, to a complete 14 unit, full arch or double arch or whatever have you. So you can really, it's the control of the restoration is ultimately in the hands of the laboratory. Whatever it is that you want to do. So it's ideal for both anteriors and posteriors and a combination of both. Again, depending on what the outcome is, and each laboratory has a certain criteria that their dentist clients have grown to expect from that laboratory. So you should still be able to do the same thing, the quality and as well as the aesthetics that your dentists have grown to expect, even easier now with the transition, because it's a zirconia that allows you to do everything from layering to full contour to everything in between in a really consistent and harmonious way. The higher chroma is in the cervical and body is where you get that attainment, but it also, what they've done with the smart incisal technology, they've also created a blue-gray effect that decreases the chroma as well as the value as it goes up into the incisal area. So that's something that's always been a challenge with zirconia, is the higher the value. But the way they've formulated this is that as they increase into the incisal edge, the value as well as the blue-gray smart technology incisal, which is a proprietary function, allows for what mimics what a natural tooth would really look like. Now, it's akin very much to the ceramic world that we're accustomed to, but yet it behaves very differently. And why do I say that? Because many of us some of us that are ceramists are programmed and know how to manipulate the ceramic product and how to, and what temperatures do to it and holding time and so on and so forth. And that sometimes translates into zirconia, but keep in mind that it's a completely different material than what we had for ceramics. So the things that we know works for ceramics may or may not work for zirconia, and it's something that you really need to know and adjust to in order to get the best results. And this is what we're going to be talking about: how to achieve that, how to accomplish that, what does higher temperatures, lower temperatures, and so on mean for you in your case. One of the great benefits of the transitions as well is the efficiency and productivity. It offers the ability of sintering in 3 different parameters. Again, depending on, it's not, depending on what kind of business model or what kind of workflow your laboratory enjoys, it could get plugged in. So certainly if there's a sintering cycle that you need a very quick, sintering to get it out the door, if you're in the same kind of same day manufacturing, or if you have a rush case or something like that, it is offered in a 4 hour and 15 minutes, as you see up here. It's a 1 ramp up, hold at 1500, and then a rapid cool. This is indicated for only single crowns and up to 3 per batch. Now it is hour and 15 minutes. So it does take about 4 hours or so, 15 minutes, but in theory, you can have 3 sintering cycles within that 4 hours. So, with the single crown, if you can do 30 per batch, theoretically, you can do as many as 120 in a 24-hour day, just speed firing. But it is a rather rapid increase in temperature, and then holds it at a high temperature of 1500 and then drops back down. If you have larger cases, specifically with 3-unit bridges or more than 30 crowns, single crowns, and again, it all has to do with mass, there is a 7-hour sintering cycle, and you can see it's actually a 3-stage of going up to 1050, and then it moves another raise of heat to 1250, and then finally 1480, which is a lower temperature than the 1480, than the 1500 rather, but you can see it incrementally goes up to where the transitions really sinter well, and then at a lower temperature of 1480 rather than the 1500. But it does take 7 hours, but you can batch in a greater way. The ideal or the best, if you're doing like you know, any kind of implant, screw retained or large restorations, anything larger than a 3-unit bridge, you should use the 9-hour sintering cycle. And I'll show you in a second how sintering actually works and how it affects, but nonetheless, the greater the mass of the zirconia, the slower and longer you need to allow the sintering to occur, so that it really sinters through and through the entire restoration. Obviously, for singles, for something that's in a rush, for something that isn't a great thickness of, you know, about 1 millimeter or so in thickness, you can do multiple singles in a very rapid sintering cycle. But if it's anything more robust, and certainly anything that has a greater mass level, I would highly suggest doing the longer sintering cycle. You just get a truer, you know, comprehensive and a holistic, really great shade, and you know, you can achieve some remarkable results with it, and have it consistently provide that solution. Now, we speak about calibration, and this is something that calibration and purging, something that is very, very important when sintering. So before even sintering, before even trying the transitions or anything like that, you know, all zirconia, and specifically also transitions, is really depending on the health of the sintering oven and how well that is, what the temperature that reads on the screen as a digital has to be the one that's really in the chamber, because it has to be throughout. Now, Zahn and Transitions have come up with a great, you know, calibration ring. And what I like about this calibration ring is that it doesn't disrupt anything. It's really, you can throw it in, you can put it into a sintering cycle regardless of the temperature. So, you know, it's not a sintering cycle that you need to do differently, or a sintering cycle that you need to do and you have to hold off on sintering your restorations because you're calibrating and you're losing time. That's not the intentions of this, and this is why I actually really, really encourage everybody to not only to calibrate at the very onset, but also to calibrate regularly, because the temperature of your sintering oven is critically important. And whether you have a silicon carbide sintering oven or a molybdenum sintering oven, both function a little bit differently. Some maintain better the heat, some not, but it's nonetheless, in order to get the chroma and the translucency, as well as the incisal that you're looking for, the smart incisal that's been designed for this, the temperature really, really has to be spot on in order to get the best results. And I'll show you some samples of what 20-degree difference will absolutely look. But you know, in order to utilize these, and they typically come, I believe, in 4 rings in a box, and it's very simple. You actually take the ring, you place it with your crucible, as you see up here, with any of your restorations all around, and you run it up in a normal fashion that you would. Once you retrieve that and it cools off, you remove the ring, and then you measure with a digital caliber to see exactly what the measurement is for that ring, because it's a function of the ring will shrink according to the temperature that it's subjected to. So regardless of what the digital meter says the temperature is on the inside, the calibration ring will reinforce or tell us that it's actually not exactly what the temperature is on the inside, because it will shrink according to the true temperature and how it behaves with this zirconia. And that's what it is. This is zirconia, and there's a shrinkage factor that then gets measured. So once you do that, you measure the digital scale, or rather the instrument, and this correlates to an actual temperature. And if you correlate this to down here, it's 1947, which you see over here on the right hand side. It really means that the temperature on the inside is running at 1506. So think about this as an example. If, we know that in order to sinter properly the transitions, we need it to be at 1480 for the 7-hour or the 9-hour cycle. If we go ahead and we do the 7 or the 9-hour cycle and we place these rings in, and now after the cycle we take a look and we measure it, the ring, and now we're finding out that the true temperature within the oven is actually 1506. That's a 26 degrees Celsius difference than what the manufacturer recommends. And that will absolutely, 20 degrees will absolutely change the way the outcome of the zirconia is. And again, it's a process of how they've manufactured it, but nonetheless, all of this really translates to any kind of zirconia. Zirconia doesn't behave in the way ceramic does. We're accustomed to, increasing the temperature in order to get, a lower chroma and maybe some more translucency, and therefore, and so far. But for zirconia, it kind of works quite the opposite. If it's too low, it'll look very opaquish. If it's too high, it'll look a lower value, but yet the chroma has been burnt out. So when you're looking at a zirconia similar, like the transitions, it's important because it's been fabricated or manufactured in a very thoughtful manner where the chroma is where it needs to be, and certainly the incisor with the smart technology and the blue and the gray is really important. So whether it's nesting, calibrating, these are all factors that will affect your end result. And oftentimes it's things that are what I consider need to be dialed in. So if you're not a transitions customer yet, I certainly encourage you, because you will absolutely love this zirconia, but give it a few sintering cycles to really get to where you want the results to be. Calibrate it first, get it to the end result, and then nesting is going to take a little bit of getting used to. So just dropping it into the CAM software may or may not provide you with the good end result, but the better we're educated, education is powerful, is power rather, we're able to then tweak it. So whether it's the temperature or whether it's the nesting, we can address any of the shade ramifications in it. Now, obviously, what do you do if we found out that through the calibration that in reality your oven is firing at 1506, and even though the digital reader says 1480, you then have to adjust those temperatures. So meaning if it's 26 degrees hotter, you'll just have to drop from 1480 another 26 degrees in order to get the true temperature of 1480. And check again with the calibration. Make sure that the temperature is reading on the inside inside of the chamber is really true to what it is that is reading on the outside. And this is something that is, as personally as regular maintenance, I would suggest perhaps doing this once a week, depending on the volume of restorations, how many times you're running the sintering oven, and so on. But it's really important to make sure that you get the best results. And with ovens, similar to porcelain ovens, sintering ovens are no different. And in fact, I would argue that because of the extreme temperatures of sintering oven, the need for calibrating and the need for maintenance is even greater than what we have in the porcelain ovens. So making sure that those temperatures are true and true throughout on a regular basis of maintenance and protocols is really important. Now, what kind of results are you getting? So one of the first things, as I said, dialing it in, making sure that you're calibrating, making sure that you're nesting in the proper place. But then after you calibrate, what are you getting? Because the results that we can see is oftentimes is very telling with what it is that we can accomplish. So here's a perfect example where, as I said, you have a restoration. These are all the same restoration. And obviously you see the one all the way on the right is the one with the true proper sintering parameter. This one, as you can see here, is something that was sintered at a higher temperature than need be. And then this one is more of on a too low of a temperature, and you see that it's very opaque and looks almost that it's just unaccomplished. Now, it's the same design, it's the same mill, it's the same puck, just fired at different sintering intervals, and therefore provide, as you can see, completely different results. Notice here what 20-degree difference makes. Obviously the ones at the top are of higher sintering values. So those are 1500, where the ones below it are 1480. But notice how different it is with just a 20-degree difference. So if you're getting these, and this is more of certainly troubleshooting, and certainly the folks at the technical support can help you through this, but it's an education, and similar to what we've done with ceramics, where we've learned about ceramics and how ceramics behaves and how to actually affect change to get it to act the way we want it to. Similarly, we have to learn with zirconia, and it's a different animal. It's a different type of restoration, although we're trying to mimic it and look as much as a natural tooth, and certainly as a lithium disilicate or any of those restorative options. But the transitions really comes as close, if not even exact, to what to restore in an aesthetic manner a tooth, a viable tooth, whether it's ceramic or zirconia. The results are truly remarkable. What you can get are very natural looking, very with the proper chroma, the proper translucency. And what you'll see, I did a study for where I milled several restorations, and it's only sintered. I do have to say, if this particular zirconia, the transitions, because of how it's manufactured, tends to behave a little bit differently than some of its competitors. For example, when you take it out of the sintering oven, it does require a vacuum, a glaze under vacuum, which does bring out the chroma significantly more. So when you're looking at it right after you're sintering, it may be lower in value, but I promise you, by glazing it with vacuum, it brings out the chroma, and it just brings it closer to the shade. Now, with that said, some shades and some crowns, well, I shouldn't say shades, but crowns, would require a little bit of enhancement with staining, but it's very minor, if any at all. But it does require a glazing with vacuum to really, bring out the fabrication, or bring out the colors to its fullest extent. The results are truly amazing, as you can see here. And this very little enhance. And again, when I say enhance with stains, it's really a product of what it is that your clientele are expecting or looking for. Certainly the shades are going to be there, but whether they want the characterizations with the higher chroma on the cervical and interproximal, whether they want some chroma in the occlusal fossas and so on and so forth, those are things you're going to have to then do externally once it's sintered. And typically, quite honestly, I get it everything within a one glaze and stain kind of bake, and off the door it goes. So right out of the sintering oven, it will be very close to the shade, but certainly with glazing under vacuum really brings it out. And you may need to enhance it a little bit with stains, depending on the shape, the morphology, and the length of your crown that you've designed. And again, each one is a little bit different. But this is a study that I've done really quickly, where I've taken all the same central from the same STL, and I milled it in different, obviously, transitions zirconia. What I've noticed is, again, you can see here that the shades are close, and certainly, and this I have to say, and I have to emphasize, is before I glazed under vacuum, which made it come significantly better. But when it's nesting properly, you can see in all of these, which are all the same type of restoration, you can actually notice a halo on the incisal edge. And these are with the light shades, you can even notice the halo. You notice the transition, certainly here, at the height of contour, perhaps you may want to enhance it slightly with a little bit of a warmer chroma, but then the 80 or 90% of the tooth is all there, and it actually transitions through very nicely, where in the incisal third you start seeing a blend of the blue-gray, as you see here, and even it's translucent enough to give it the very much appearance as though it's something that has been layered or something that is very natural. And I've done this again for the A1, A2, A3, A3-5, and you can see certainly the darker shades get a lot closer. The lighter shades do have that higher value that you sometimes have to enhance with a little bit of stain. But look at the D2s and even the C3s. These are restorations or shades that are typically very difficult to attain with any of the other zirconias or any of the other type of within this class. It's certainly an evolution and a premium type of zirconia, and you can see that with the blue gray, the smart incisal technology, it actually lowers the chroma, or rather the value. So here you have, again, slightly, you may want to just enhance it with a little bit of stain, just the cervical and perhaps interproximal. But then you look, this is true to chroma color, and then it drops a little bit of the value, which makes it very aesthetic and very natural looking. Here again, you can see in the B1 that we have the halo akin to what we can see here on the shade tab. So the similarities, and these are just sintered and hand polished. Certainly the warmth comes out significantly more once you glaze under vacuum, which is a criteria for this zirconia, because it does behave, or does help it behave, where it brings the chroma out greater. But what you get is a honest and true to color. Now, with that said, again, perhaps, and depending on the type of business model you have and what kind of your clientele expect from your laboratory, there are times that you're going to need to stain and glaze, but it's always going to come true to shade. But enhancement or characterization is something that the laboratory is still going to have to add. Again, depending on what it is, depending on how characterized you need your restoration. The beautiful part of this is that you can utilize, whether it's Emax or luster paste or anything, you don't have to buy a whole new system in order to glaze and stain. In fact, I use the luster paste for all my zirconia type of restorations. But by doing that and glazing under vacuum and with very, very minor superficial glaze, and again, the glaze is not to achieve the shade. I mean, rather, the stain is not to achieve the shade. The stain is purely just to enhance the shade, and less the shade, more so the restoration. Because the natural tooth really, on the interproximals and the cervicals really have a higher level of chroma that you may have to enhance it. And again, it's to get closer to the shade tab and ideally closer to what the patient has in their oral environment. So I'm really encouraging all of you to try the transitions. Please do calibrate it. Please make sure that you're running the temperature that is proper and correct inside your sintering oven. What the meter says is, and hopefully can be correct, but sometimes it may need to be manipulated. And over time, as you're using your sintering oven, it too, the heating filaments or the elements, can either, sometimes I've seen them actually diminish in power and heat, or actually increase depending on kind of the malfunction that it goes. So making sure that you're purging and calibrating your sintering oven is what's going to give you those end results, because it's what's baking the zirconia, and the chroma and the incisal technology and the transitions will really make your production more efficient and easier to get to the end result. So with that said, I'm open to any questions. I want to thank everyone again for your time. Hopefully you found great value in this, and certainly it's a fantastic zirconia that I've had the opportunity to test it, but it does require a little bit of dialing in, which once you've dialed it in, you're off in the gates and running. So it's just perhaps 1 or 2 or 3 crowns just to get it to know that your equipment operates and works true to what the manufacturer, and then making sure that that translates to the restoration with the nesting and so on to get the end result. Once you get the great end results, which you may very well get it right off the bat, but sometimes it requires a little bit of dialing in with, like I said, maybe 1 or 2 or 3 sintering cycles. But once you've dialed it in, you're up and running and running with this. And you can use it from a single restoration all the way to a full 14, a roundhouse of zirconia of sort. And you can layer it, you can glaze and stain it, whatever the case may be. It's a great workflow for any laboratory. So thank you for your time. If we have any questions, I'd be happy to answer.
Yes, thank you so much, Daniel. We did have a question. I believe you touched on it already. So basically, a customer of ours has already calibrated their furnace and has indicated that they received a shade that was lighter than what was to be expected.
Mm-hmm.
What would be the best approach?
So if in fact it was calibrated and adjusted for whatever it was found, so if in fact it was running too low, too hot, or whatever have you, and it was adjusted in the program to accommodate that, that would be my first step. The second step is to really examine the nesting, because again, there's a bottom which is higher in chroma, and as it goes up towards the incisal edge, you get more yttria, but then also more of the smart incisal, the blue and the gray. So you want to really select the right size puck so that you nest it in its appropriate position so that you benefit from the whole transition from chroma all the way to incisal. And then you want to make sure that you nest it properly towards the bottom of it so that you can capture that chroma. What happens sometimes that, with certain CAM software, depending on the CAM software, it will fill that space and have it towards the incisal edge because it wants to mill less material. Especially if you really need a 14 millimeter and you're using a 16 millimeter, it's going to bring it closer towards the incisal edge and therefore divert your shade outcome. And lastly, glazing with vacuum will really warm it up and make it look more viable in many ways. So that's kind of like the process that I would go through, making sure that the oven is properly functioning, then making sure that the nesting is correct, then glazing it, then you should be able to attain those results. Again, you may need to just enhance it a little bit if you need to warm it up, but it shouldn't be a complete shade off. It may be A2 and you really get an A1.5 for argument's sake. So you may need to enhance it a little bit on the cervical just to make it pop, and you get the results that you're looking for with the incisal that you're looking for. That is very, very good with the transitions.
Thank you, Daniel. All right, if you guys have any other questions, please don't hesitate to reach out to a Zahn representative. We are out of time, but I did wanted to remind you that we do have a webinar coming up for desk components that Daniel will be joining us on in a panel discussion on February 18th. We encourage you to join us for that. And also there will be another Zirlux Transitions quick bite on March the 24th, where we can learn more about this fantastic product. We thank you, Daniel, for all of your knowledge and expertise this morning, and I thank you all for joining. Have a wonderful day.
Thank you.